Okay, so today we're going to talk about similar figures. Yesterday we talked about the Pythagorean theorem. The Pythagorean theorem allows us to find side lengths of triangles, but there's a but there, right? What kind of triangles does the Pythagorean theorem work with? Right triangles, and only right triangles, okay? So what we're going to learn today is how to find side lengths of triangles that maybe aren't necessarily right triangles. Now here's the thing. Using this method, this idea, we can't just have one triangle like the Pythagorean theorem, and if I have two sides I can find the third. I have to have two triangles. And what these triangles have to be is they have to be what we call similar triangles, okay? So similar figures don't necessarily have to be triangles. They could be quadrilaterals. They could be circles, I suppose. I guess all circles are similar. They could be rectangles. They could be stars. They could have as many sides or points as they want. But they have the same shape, but not necessarily the same size. So these two triangles here, if you laid them on top of one another, they would be the same shape, but one's bigger than the other, okay? Doesn't necessarily have to be a different size, but same shape, not necessarily the same size, and most of the time they're not the same size, okay? Now the important cool thing about these similar figures is that since they're the same shape, the corresponding angles, so in other words, if I did lay them on top of each other so they looked alike, so this one I'd have to flip it over. If I did lay them on top of each other, the corresponding angles, so it's going to be angle A and angle D, those would have the exact same angle measure. And angle C and angle E would have the same angle measure, and angle B and angle F would have the same angle measure. The corresponding angles, the measures would be the same. Which doesn't really help us find the side lengths though, right? Okay, the angles are the same, that's cool. That doesn't tell us anything about the side lengths. How we're going to find the side lengths is another property of similar figures is this third bullet here says corresponding sides of similar triangles or similar figures are proportional. So what that means is if I write a proportion of this side length to its corresponding side length, that is going to be the same exact proportion as if I took this side length over its corresponding side length. Okay, so maybe it sounds kind of confusing once we get into some examples. Hopefully that'll make a little sense. So we can use this information to find missing angle measures and side lengths in some of these figures. So first thing I want to do is I want to talk about the corresponding angles and the corresponding sides. Because a lot of times you can look at the picture and you can kind of visualize. Maybe if they're not oriented the same way, you could at least say, oh, well, I know that this angle would go with this angle. But the cool thing is, this right here at the very top says triangle ABC is similar to triangle DEF. And it's important because it tells me these two triangles are similar, but what's even more important is it tells me which angles are corresponding. Since A comes first and D comes first, those two angles are corresponding angles, which makes sense. They look like they would be corresponding angles. Angle B and angle E, those are corresponding angles. Same thing with angle C and angle F. So without even looking at the picture, you could tell me which angles have the same measure. Do you guys see that? Now, what's going to be more useful today, using kind of the same idea, you can tell which sides are corresponding as well. So let's write down these sets of corresponding sides. We're going to set up the ratios, and we're going to be doing this over and over and over again today. So without even looking at a picture, I can look here and I can say that side AB corresponds to, and since AB comes first in my name, that corresponds to side DE, which makes sense. AB, DE. It's flipped a little bit, but those two sides are the corresponding sides, okay? We could also say that BC, so this would be a completely separate ratio, but side BC, which side would it correspond with in triangle DEF? EF, the last two letters in the name. And then my last side would be side AC. Which side of my second triangle does side AC correspond with? DF, the first and the last letters. So once again, without even looking at the picture, I don't even need the picture. I can tell you what my corresponding sides are. I can tell you what my corresponding angles are. Now what this third bullet tells me is that if I actually have numbers up here, so if I tell you how long ABC is, how long AB is, these ratios would all be equal. That's how we're going to use this information to find some missing side lengths. Okay? Now I will put a little disclaimer on this today. 2 disclaimers. 1, we're going to have to draw some awesome, incredible figures. Make sure you get them labeled correctly. In your homework, they're already labeled for you. The picture's already drawn, but in your notes, you got to do the drawing yourself. Secondly, in the notes, to kind of get the point across, they're going to be nice, easy, whole number answers. Your homework, they're going to be decimals. Okay, but you guys can use your calculators if you want to get out your calculators now to help you a little bit. I'd be okay with that. But for your homework, I'm telling you now, a lot of decimals, but since you're using calculators, not a huge deal. Okay, so I have 4 of these examples. So if you want to split your paper into 4 boxes, you can. I'm just going to kind of make boxes as I go. So for the first one, I'm going to tell you that triangle PQR is similar to triangle XYZ. Triangle PQR is similar to triangle XYZ. Now remember that I said without even drawing the picture, I can tell you which angles are going to measure the same. I can tell you which sides are going to be corresponding, right? Angle P and angle X, they're going to measure the exact same thing. Angle Q and angle Y, they will measure the exact same thing, and angle R and angle Z will measure the exact same thing. PQ and XY are going to be corresponding sides. QR, YZ, those are going to be corresponding sides. PR, XZ, those are going to be corresponding sides. Without even looking at the picture, I can tell you that. You guys see that? Okay, well, let's look at a picture. We're going to have 2 right triangles. So this first one, this is going to be PQR. Make sure you label yours the same way I do. And my next triangle is going to be just a little bit smaller. Same shape, not the same size, and that's going to be triangle XYZ. And then I'm going to tell you some values of these triangles, and we're going to find all of the missing values. So let's say that PR measures 8. RQ measures 6. PQ measures 10. And then on the other triangle, XZ, we're going to say that measures A. So we don't know what that angle measure is. We're going to end up finding that. ZY measures B, and XY measures 5. Okay, so here's what I like to do. Not necessarily a right or wrong way to kind of go about this. Here's what I like to do. I like to set up my corresponding angles, and then if I can fill in the values, I'm going to do that. So let's do that. Let's start with PQ. And we're going to write this as a ratio. So looking at the names. And this one's a little easier because they're facing the same way. And you can see that PQ, by looking at the triangle, that's going to be its corresponding side. But you can double check by looking at the names. PQ, XY. So I'm going to write PQ over XY. And then I'm going to fill in the values if I know them. Well, PQ measures 10. XY measures 5. Okay, make sense? Okay. Now, here's one thing before we go on to the next one. If I am going to write my ratio as triangle PQR in the numerator and triangle XYZ in the denominator, I've got to do that for every single ratio. If you want to flip it, that's okay. But you've got to flip all the ratios. So I usually pick the first triangle, that's going to go in the numerator, second triangle, that's going to go in the denominator, just to stay consistent, but you don't have to. As long as you stay consistent from one triangle to the next. Make sense? Okay? So let's pick another side. So let's say we have PR. So side PR, which side corresponds to side PR? XZ. Okay, and what does PR measure? 8. And what does XZ measure? A. And then the last one, what's my last remaining side? RQ, QR, whichever one means the same thing. And which side corresponds to QR? YZ. And what does QR measure? 6. And what does YZ measure? B. Okay, once again, don't have to do this, but this is the way I found that is easiest. You have everything worked out. You have everything set up before you. Now what I need to do is I need to figure out what this is. I need to figure out what this is. Remember that first thing that I told you up there? What do I know about all of these fractions, all of these ratios? They're equal. They are equal. So once you do this, you should have a ratio where you have both of the values. So I'm going to use that ratio. I'm going to use that 10 over 5. And I'm going to set it equal to one of the ratios that maybe I don't know what one of the sides is. So maybe I use this second one here. So I'm going to say 10 over 5 is equal to 8 over A. Okay, well this is a proportion, right? Do we know how to solve a proportion? How do you solve proportions? Okay, cross multiply, right? We're going to multiply up and across. 5 times 8 gives me 40. 10 times A gives me 10A. Divide both sides by 10. So I know that A equals 4. I have found one of my missing sides. Okay, and we're going to do the exact same thing, except this time, instead of using 8 over A, we're going to use 6 over B. So let's use the 10 over 5 again, and I know that all of these ratios are equal, so I know 10 over 5 equals 6 over B. Let's take the same steps, use your cross product. 6 times 5 gives me 30. 10 times B gives me 10B. Divide both sides by 10. B equals 3. Make sense? Yes.
Can you just, like, you can see that 10, is, or 5 is half of 10, so couldn't you do, say, what is half of 8, so that's 4, and then half of...
If you notice those patterns, I'm okay with doing that, but we're not always going to have a nice pattern like that, so you need to know how to use the cross products in case you need it.
Oh, you're showing us how to do this.
Right, because this isn't always going to be a nice half or a third, or there's not going to be a nice relationship there, especially on your homework today, because you're going to have decimals. So if it's not, we need to know how to use the cross products to solve, just in case if there's not a pattern. Does that make sense? Mm-hmm. Okay? All right, any other questions on the first one? What do you guys think? Not too bad? Okay. All right, let's look at the next one then. Okay, our second one, we're going to have triangle A, B, C is similar to triangle A, D, F. Triangle ABC is similar to triangle ADF. Now notice, what's something you notice here? They share an angle, right? They share angle A. Well, that's interesting. So this picture is going to look a little different. This time, we're going to have this big triangle here. This triangle is triangle ADF. So this is my second triangle, my bigger triangle. My other triangle is inside that triangle, and this is triangle ABC. So one picture, two triangles, they're similar. Angle A is congruent to angle A, well, duh, okay. Angle B is congruent to angle D, so these ones here. And then angle C is congruent to angle F. You have a question? Yes.
How would you know how the picture's going to look?
I'll draw the picture for you.
Okay.
Yeah, so this is already drawn for you, and I'll give you the measures and everything like that. All you have to find is the side lengths. You won't have to do any drawing. Okay? So this time, since the sides are kind of combined, right, because AF, that is kind of two pieces to a side, instead of really telling you what they are, they're just going to give you some information. They're going to say AD equals 25, BC equals 3, AC equals 6, and AF equals 10. Okay, so once again, don't have to do this step where you set up the ratios, but I promise you, it's going to save you a little bit of work and it makes it a little bit easier. So let's set up the ratios here. So let's start with just looking at the name, yes?
Well, confused. How does AD equal 25 is an AF?
It's not drawn to scale. So it's not drawn to scale. Although it looks like they are the same, you cannot assume that they are the same. It's not drawn to scale, and that's my other disclaimer on your homework today because I drew all the pictures. They are not drawn to scale. So even though they look like they're the same or look like they're close, you cannot assume that they are unless they tell you. Okay? I just didn't want to go to the work of drawing it to scale. So, okay, so let's set up our ratios. Don't even need the picture to do that. So let's start here. If I have side AB, which side corresponds to side AB? AD. AD. Okay, do I know what either one of those is? Oh, and then, hold on. We're going to say that this is X and this is Y. That would help if we had those two. This is X, this is Y. Okay, so do I know what AB measures? Do they tell me? No, that's X. Okay, so that is going to be X. Do I know what AD measures?
Yes.
25. They tell me that over up to the right there. Okay, let's pick another side. What's another side in triangle ABC? AC. Which side corresponds to AC? AF. Okay, do I know what AC measures?
Yes.
What is it? 6. And what does AF measure? 10. There's my magic ratio here. You got to have a ratio that has both of them. So this is the one we're going to use a lot. And then for my last one, what's my last remaining side there? BC, which corresponds to DF. Okay, BC measures 3, DF, that's where my Y is. Okay, so I have my 3 ratios. So now we need to set it up. Let's set these two equal to each other first. So I'm going to have X over 25 equals 6 over 10. And just like the last one, use our cross products. 25 times 6 gives me 150. 10 times x gives me 10x. Divide both sides by 10. So x equals 15. That side AB measures 15. Okay, and then we're going to take our other two. We're going to set 6 over 10 this time equal to 3 over y. And multiply up and across, so I have 30 equals 6 times y. Divide both sides by 6, so y equals 5. Okay, once again, your homework isn't going to be these nice easy numbers. You're going to have some decimals. It's not going to work out super easy, but same steps, same procedures. Questions on that one? Okay, 2 more to go here. Okay, this time we're going to have triangle ABC is congruent to triangle EDC. Okay, this time my triangle, I'm going to have this big one here. It's going to look kind of like an hourglass, a little lopsided hourglass, a little bit. Once again, I'm sorry, my pictures are terrible. I'm trying my best. Okay, and then this is going to be A. This is going to be B, C, D, E. Okay, and AB is 18. AC is 12. BC is Y. CE is X. CD is 10. DE is 12. Okay, here's what I want you guys to do. I want you guys to set up those proportions, those three ratios of the corresponding sides. Fill in their side measures if you have them, and then check with what I have on the board. If yours matches what I have on the board, go ahead and solve for X and Y. Okay, let's go ahead and talk through these. So we set up our proportions. Once again, don't even need the picture to set up these proportions. Kind of need the picture to get the measurements. But that's really the only thing you get from the picture. Don't need to find the corresponding sides, corresponding angles according to the picture. We can do that according to the information that we're given. So we have these three ratios. If I set 18 over 12 equal to y over 10, solve for y, we should get y equals 15. And then if I set 18 over 12 equal to this last ratio here, 12 over x, we should get x equals 8. Did anybody not get those? Not sure why? Questions on how we got any of those? Okay, for this last one, I'm going to draw the picture, do a tiny bit of explanation, and I'm going to have you guys do it all on your own, okay? This one's going to be just slightly different. This time, it's going to tell me A, B, C, D is congruent to E, F, G, H. What's different about this one?
They're not connected.
There's 4 letters. What do those letters represent? It's going to be a 4-sided figure. There's 4 points. It's a 4-sided figure. It's a quadrilateral. But guess what? It doesn't change anything. Same thing. Angle A is congruent to angle E. Angle B is congruent. There's just 4 sets. And same thing. There's 4 sides. AB is congruent to EF. BC is congruent to FG. CD is same thing. Same exact steps. Now with the 4-sided figure, one difference is there are some points that don't form a side, right? If you think about a square, the ones that are diagonal from each other, that's not a side. So AC, for instance, that's not a side of my quadrilateral. BD, that's not a side of my quadrilateral. Does that make sense? Okay, only the ones that are next to each other. Now AD would be, because they're one's in front, one's in back. Okay, and then your picture, this one's going to be interesting to draw. It looks kind of like a trapezoid. And that first one is A, B, C, D. And my second one is turned a little bit. Once again, not drawn to scale whatsoever. And we have F, E, H, G. Okay, and I'm going to tell you that AB equals 5, BC equals Y, DC equals 25, GF is 4, FE is X, GH is 10. So go through the same steps, set up your ratios. How many ratios will you have? For a triangle we had 3. How many do you think we'll have for a quadrilateral? 4. You'll have 4 ratios. You may not be able to fill in all of the ratios because I may not know any of the side lengths, and that's okay if that happens. Okay, so once again, like I said, you have 4 ratios. Don't know information for all 4 ratios, and that's okay, but it's good to set them up anyway. So I don't know anything about the AB to EEH, but we set it up anyway just in case we need it. And then we notice that the CD over GH, that's the big important ratio. Got to have one that has a numerator and a denominator number. And set our ratios equal to each other. Should get x equals 2, y equals 10. Questions about any of these examples?